The Power Query tool is incredibly powerful and incredibly detailed. It can be used to pull data from external data sources as diverse as websites, Access databases, other Excel files, or even JavaScript objects. As a result, like the pivot tables, I could probably spend an hour or more discussing the different ways to use the Power Query tool. For this course, we're going to use the Power Query tool strictly within Excel to work around some of the limitations imposed by the lack of true Power Pivot support for the base Excel installation. The result will be a fairly high-level introduction to the tool and a solid example to follow for learning how to further extend its usefulness for your own needs. First, the Power Query tool builds off of an initial dataset, so while it's possible to create a blank query, doing so is very challenging. We need to design a query that merges our products and line items tables together. So we'll start by using our products table, and we're going to add it as a query quite quickly. So at our products table, we're going to select the entire table. We're going to go to Data, and under the Get and Transform tools, which is what the Power Query has been relabeled as in 2016, we're going to create a query from the table. This action opens a whole new window called the Query Editor. This editor has its own ribbon, which will allow us to modify our new query with a whole host of database-like functions. For now, we're going to simply close and load to, and we're going to select Only Create Connection, and I'm going to press Load. This creates a query from our product table and opens up our Workbook Queries window. We'll be able to reference this query from other queries, which is what we'll need to incorporate the products directly into the line item table. Since we want to merge this with our line items table, we're going to go to our line items table and do the same thing that we did here. We're going to select the whole table, we're going to go to Data, and we're going to choose From Table to create a new query. Now let's learn about this query editor in some detail. Each of the actions along this ribbon does not permanently create a change. Rather, it adds an entry in a list of to-do items in order to generate a dataset. This list of steps can be seen to the right under Applied Steps. This means that each time you perform an action, it'll get added to the list and you can visualize the data at any given point in time to understand what is happening with each step. For example, I can select the ID field and use this Remove Columns button to eliminate the ID field since I don't need it for anything. This has added a Removed Columns step to my Applied Steps. I can see the data before by clicking on the Change Type, and the ID reappears in my field. But now, what did we come in here to do? Since we don't have Excel's self-service business intelligence, we cannot use the data access expressions, DAX, to create calculated fields directly in our pivot tables. As a result, we're going to create a Power Query that merges our products and line items tables together and then calculates the information we need within. So the key word I used there was merge. This is portrayed as a merge queries option under our combine options. You could also append queries, which simply stack data on top of one another. So I'm going to click on the merge queries, and this pops up a brand new merge window with our current line items table at the top and a drop-down below that. The drop-down will allow us to select any of the other Power Queries within our workbook. I'm going to select the products from that drop-down, and it will show me all the fields available to me. Now at this point I need to define a true database-style relationship between the two tables. Selecting the correct join will depend upon your data needs and your visualization needs. For our data, I'm going to define an inner join, which will only bring matching rows from each table together. A left outer will take all of the entries from the first, whether they match or not, and provide matching rows from the second, so you might lose some rows from the second table, but you'll never lose rows from the first. The right outer does a mirror image version of the left. You'll get all of the rows from the second product, whether or not they match something from the first, and you'll only bring in the rows from the first that match. The full outer will bring all of the rows from both and match them up as best as possible. The inner will bring only those that have matching values in each set. And then the left ante and right ante provide versions where they only pull the rows from the first or from the second. For our purpose, we want to only show rows where both of them have a match. Once we've selected the join kind, we need to identify what fields to perform the join on. Our join will match the product ID from the line items to the product ID on the products. This is the same approach as the relationships, except now we're defining a truer database-style relationship. Once we've done this, we can press OK to update the query. This has appended a single new column onto the end of my query which has table for each of the values. It's also got a funny little arrow symbol, so if I click on that, I can see all of the columns that are crammed into this single column, and I can choose to expand them. If I didn't want to include any, I could deselect them. Since I don't need product ID twice, I'll deselect that and press OK. I've now got a table that contains almost all of the information that I need for the invoice table, but I still need those calculations. Each calculation will be a column, so we're going to go to the Add Column ribbon and add it from there. I want to add custom calculations, so that's going to be done using the Add Custom Column command. These columns can perform a wide variety of calculations using the available columns and some special functions. For this course, I'm going to avoid the functions as they will work differently from your typical Excel formula bar variety and have a completely different syntax. Now this column is going to be our total revenue, so I'm going to give it that name, and I'm going to add the formula as being equal to sales price, adding columns simply by double-clicking, multiplied by quantity. Once I've specified my formula, I can determine that there are no syntax errors below, and I can press OK. Doing so has added a new column to my table where the total revenue is equal to the sales price times the quantity. I can do the same thing for my total cost of goods. After creating these fields, we need to make sure that they're treated as if they're numbers. So we're going to go to the Transform tab, and this allows you to do a whole bunch of things to change the actual data structure of the fields. So I'm going to select the total revenue and the total cost of goods fields, and under the Data Type option, I'm going to select a decimal number. This means that it is a number with some type of decimal places. This makes sure that the pivot table treats them as if they're numbers, because sometimes the pivot table might think they're in text or some other non-numerical value, which makes sums, counts, averages, and other functions behave differently. Once we've created these two fields, we need one more field, and that's our profit field. And again, we're going to do the Add Custom Column. Going to call it Net Profit, and our Net Profit field can actually use our other two calculated fields. So I can use Total Revenue minus Total Cost of Goods. Again, we need to make sure that it's a number value, so I'm going to change it to a decimal number. At this point, we'll go back to the Home tab, and before we finish, we want to make sure to rename our query from Line Items, since we already have a table with that name, and we're going to call it Invoice Support. Once I've done this, I can choose Close and Load To, and I'm going to only create a connection, and I want to add this data to the data model, and I'm going to press Load. By adding it to the data model, I can now go to my Data tab, go to my Relationships, and I can create a new relationship, or my table here is my Invoice Support table, and I can use its client code to map it to the client list, just as we did with the other tables. I can press OK to generate that relationship. Closing my Relationships window and going back to my pivot table, I can now see that I have a new table called Invoice Support as an option. I'm going to get rid of my current values, my current cost of goods sold, and my description, and I'm going to use all of the fields that I need from the invoice support. I'm going to bring sales price, quantity, cost of good, total cost of good, total revenue, and net profit into my values field. Then I'm going to use the description field as my row column. And now when I select the client code, I have the list of the widgets, the sales price, the quantity, the cost of the goods, the total cost, the total revenue, and the resulting net profit. All like our original invoice template, and all easily reorderable simply by dragging and dropping. Now I'm going to make one more adjustment. Instead of using this filter, which is kind of ugly and kind of challenging to use, I'm going to get rid of it. I'm going to replace it with a slicer. So for a pivot table slicer, we can go to Analyze under the pivot table tools, choose Insert Slicer, and I'm going to use the client code. Press OK. And now we have an invoice that uses the client code. I'm going to make it wide instead of tall, and I'm going to give it 8 columns. And now we can pick and choose and define our invoices using our slicer. The slicer works just like it did for the table, and now I have a basis for an invoice template that does not use formulas at all, while having a variable number of rows and entries. While the formatting isn't quite there, you can easily apply your own formatting information, set the columns and the rows and all the different font features, and then add some additional lookups to generate the address details and referral details using the same general approaches in our original invoice. Now let's use all that we've covered to complete exercise number 7. For exercise 7, you can start with either your solution to exercise 6 or my solution to exercise 6, which is the exercise 7 file. Now each of the tables has been normalized and the relationships have been defined. Your goal is to create 2 pivot tables. The first should summarize the average number of hours worked for each employee, and since this is a straight relationship, the Power Query will be unnecessary as you'll be able to calculate the average using a pivot table built upon the data model. The secondary pivot table should calculate the total amount earned by each employee. This will require the Power Query tool to add a calculated field using the same approach that we just used in this lesson to calculate total revenue. My solution will be made available to you, but there are different routes you can take, so you should focus on getting the right outcome. Our next lesson will look at how to extend pivot tables with pivot charts for an added level of data visualization.